Right, so intermolecular forces and intermolecular forces refers to the forces due to interactions of molecules, and the reason we're interested in those is that they're useful for explaining properties of substances. Okay, so the properties of substances pretty much depend on the strength of the attractive forces among the particles that make up your substance, okay, like the molecules. And generally, if you have stronger attractive forces, it leads to higher melting point, higher boiling point, higher viscosity, and higher surface tension. Let's try to understand why it requires higher boiling point or higher melting point when you have stronger forces of attraction among your molecules. What happens when your molecules are strongly attracted to each other? It's harder to spread them out, right? It's harder to pull them apart. So what happens in boiling when a liquid boils? You're spreading out your molecules. So it takes more energy for them to overcome those forces of attraction. So you would expect a higher temperature. A higher temperature simply means you have more energy for your molecules. Same thing with melting point. Going from solid to a liquid, in the solid, the motions are more restricted. There's more freedom of movement in the liquid as opposed to a solid. So for them to have that, the ability to move better, okay, they need to have a higher energy. Okay, if you have a stronger forces of attraction among the molecules, you need a higher energy to overcome those forces of attraction. Viscosity is the resistance to flow. Okay, and so that's also associated. Higher viscosity is also associated with attractive forces. Surface tension. Surface tension has to do with increasing the surface area of your sample. Okay, so that requires movement of molecules from the bulk to the surface. And anytime you move molecules from the bulk to the surface, that also requires energy. So surface tension is in fact defined as the energy required to increase the surface area. So that again, that involves overcoming forces of attraction among the molecules. Okay, so stronger attractive forces would lead to higher melting point, higher boiling point, higher viscosity, and higher surface tension. Here's an example. What does the fact that oxygen, O2, is a gas, while H2O is a liquid at room temperature imply about the strength of the intermolecular forces? O2 is in the air that you breathe. It's about 20% of the air you breathe. It's a gas at room temperature. Whereas water, water is what? Water molecules are much closer together at room temperature. It's a liquid, right? So what does that mean? In which case do you have stronger attractive forces among the water molecules? Okay. In fact, that means that your oxygen, what would you say is the boiling point of oxygen? It's going to be way below room temperature, right? If it's already a gas at room temperature, that it must, if you imagine it was a liquid at some low temperature, it would boil at a very low temperature before you even reach room temperature. It's already a gas at room temperature.